Welcome to my channel. Let us discuss projections of points. In it, what is point? Point means, as we know, it is a dot. Okay, so single one dot like this. It has no dimension. Okay, no width and no height and no thickness. Okay, it has no dimensions. It is called point. So in it, what is projection? Projection means it is a image or drawing of any taken object. Okay, whatever object we are taking, if we are doing the drawing on the plane, so it is called projection. Okay, so projection means it is a image or drawing of an object made on a plane. Okay, here we are doing the images of the points. Okay, here as I told, we are doing the images or drawings on a plane. Okay, which plane we are taking? Okay, plane surface we can take. Here we are taking an engineering drawing horizontal plane. Okay, HP we are writing shortcut form, and vertical plane, that is VP. As we know, angle between vertical plane and horizontal plane is 90 degrees. This side also 90 degrees. Okay, here these two planes are dividing this entire area into four parts: first, second, third, fourth. There are four quadrants we can call. This is the first quadrant. This is the second quadrant. And this is the third quadrant. In shortcut form we can write Q also. This is the fourth Q. Okay. Let us take position of the given point. Okay. Here whatever points are coming this side, those are in front of VP. Whatever points this side coming, those are behind VP. Similarly, this is a horizontal plane. Whatever points are coming above these planes, those are above HP. Whatever points coming below horizontal plane, we are telling those are below HP. Initially, I am taking A point. So, how to define the position of A point? Is it above the horizontal plane? Yes, it is above the horizontal plane. Is it in front of vertical plane? Yes, it is in front of vertical plane. So, how to locate A point means we have to tell A point is situated above the horizontal plane and in front of vertical plane. Okay. So, similarly, give the location of B point. It is above horizontal plane, behind vertical plane. Similarly, take C point. It is below HP, behind VP. Take the D point. It is below HP, in front of VP. Okay. Now I am taking one point here. It is the E point. So how to locate E point? How to give the position of E point? It is on the HP, in front of VP. Let us take one point similar to E point. I am taking F point here. How to locate F point? F point is on the HP, behind VP. Similarly, take one point here, G point. How to define G point? G point is on the VP, above the HP. Similarly, take here H point. H point is below HP, on the VP. Okay. Like that, we have to give the position of each point. Initially, in giving location, we have to tell that point is from the HP, and next that point is from the VP. Okay. So like that, we have to give the location of all the points. I am taking one point here. Okay. I point. This I point is, how to define I point, how to give the location of I point. I am taking intersection of horizontal plane and vertical plane. I point is on the HP, I point is on the VP. So it is nothing but on the intersection point of vertical plane and horizontal plane. Here, as I told, we are doing the drawing of the given point. Okay, what type of drawing we are doing? We are doing in projection front view and top view of the taken object. Here it is a front view of the point and top view of the point. Where we are doing this front view and top view? We are doing on the plain paper. Okay. So here in engineering drawing, we can do on the horizontal plane or vertical plane, or in the area between horizontal plane and vertical plane. That is first Q, second Q, third Q, fourth Q, like that. Here, for doing the drawings of the points, we are taking 4 points. In the first Q, A point here. In the second Q, B point. In the third Q, C point. In the fourth Q, D point, as examples. Okay, for A point, we need to do the projections. Projections means here we have to take front view of A point. We are taking front view names C dash, B dash, C dash, like that. and we have to draw the top view of the given point also, that is small a, small b, small c, like that. Okay, these drawings we can call it as projections. So we need to do the front view drawing and top view drawing of a given point. Let us take a point initially. So front view means from our eye we have to see front of this a point, okay, in this direction. And top view means from our eye we need to take exactly, it is coming here, top of the point. Okay, this is the top view. In the shortcut form we are writing TV here, FV. Okay, so let us assume these are the transparent planes, horizontal plane and vertical plane. If we see from our eye this point, we can see the projection, okay, front view projection, that is a dash on this vertical plane. And if we see from the top of this point, we can see the top view of the a point. Okay, front view is coming on the vertical plane and top view is coming on the horizontal plane. As I told, it is a drawing of front view and top view of the given point. So the drawing is nothing but we can see the dot here on the vertical plane a dash. This gap is 38. Okay, whatever gap is there, it is also 38 here. If we see from the top here, this gap is 31. So at 31, from this point we can see a. Okay, so here these are the projections of the a point. So for marking the projections, every time we can't take right angle triangle paper, we have to mark this is a dash, this is a. Here I am showing this vertical plane and horizontal plane in the given model like this. Okay, this is the horizontal plane, this is the vertical plane. If you are keeping here, okay, as I told, front view is coming here, okay, that is a dash, and top view is coming on this plane. Okay, let us, I am taking, this is some a dash. Okay, so a dash is coming here and a is coming here on this plane. Okay, on the same line, because we are taking common point. Okay, both is nothing but front view. Okay, I will write here FV, and this is the top view, that is TV. Both will coming on the vertical plane as well as horizontal plane. We can't do like this every time in the 3D. That's why what we are doing, we are tilting this horizontal plane in downward direction like this. This part here means this will go in upward direction. Here it will go upward direction. Here this part is coming in downward, so it will coincide with the vertical plane. Okay, the final front view and top view will come like this. This is XY line. Above XY line a dash is coming, below XY line a is coming. What is a dash length? Whatever length is there, 38. Take 38 here. Whatever this length is coming, 31, as I told. Okay, this is the 31. This 31 is coming here. So this is a 2D diagram of the projections of this a point. Okay, so for doing the projection, first we need to do the XY line, okay, which is passing through vertical plane and horizontal plane. Here do the XY line of any length. Okay, so I am doing here XY line of some length. So this is the XY line. Just write down XY here. After doing XY, mark a dash 38, okay, above the XY line. So I will start here from here. So this is 38. Taking this is a dash. And then what about A? A is 31 mm below XY line. So this is the A point. Here remember A dash and A are coming on the same line. This is called projector. Okay, so for doing the projections, here these points A dash and A should be in dark color, and this projector line is in light color. Okay, so let us mark these points dark, and this, no need to write front view, top view like that. Just mark A dash A for the capital A point. Okay, and then here for dash we have to keep for the front views, and then for top views without dash we have to keep small letter. Okay, this is a projection of the A point in 2D diagram. Okay, this is a representation in 3D diagram. This is in 2D diagram. So why we are converting 3D into 2D means every time we can't show in the right angle triangle paper these projections. For reducing the time, we are marking on the 2D diagram. Okay, mark the dimension for A dash and A. Okay, A dash, as I told, it is 38 mm above this line. Okay, so here just do the extension line. Just mark here, this distance is 38. And what about A point? A is coming here, top view. How much distance it is? 31. Okay, so A is 31. Just do the same extension line of this dimensional line. Here just do the extension line. Here mark 31. Now let us take the B point. So for B point, so front view should come from this direction. Okay, we can see the B point like this, and top view is like this. Okay, observer is standing here. Okay, let us assume this vertical plane and horizontal plane are transparent planes. We are standing this side only. Okay, we can see this B point through this transparent plane. B point here, it is the front view of the B point. And what is the top view? So top view is from the top of the B point. Okay, we can see the front view of this B point here on this plane, vertical plane. Okay, we are marking it is B dash. And then top view of the B point, top view we are giving small letters. Top view we can see on this, it is a B. Front view is coming on the vertical plane and top view is coming on the horizontal plane. B dash and B mark in the taken model. So here we took this model. Okay, so this side is A point, this side is B point. Okay, so B dash is coming on the vertical plane. How much distance it is? 48 mm. Okay, now I'm marking this B dash on the vertical plane. Okay, so here mark B dash. How much distance it is? 48. Let us take, this is the XY line here. So from here it is a 48. Okay, to mark B point, that is top view. How much distance it is? 21 mm on the horizontal plane. So this is the horizontal plane. We need to mark 21 mm distance. So here on the same line, projector line, so 21 mm distance, we need to mark B point. Okay, this is the front view, this is the top view. Okay, now after that, now after marking B dash, it is a 3D view. Okay, now we have to convert in terms of 2D view for reducing the time. So what I told, we have to tilt this horizontal plane in downward direction so that this horizontal plane will coincide with the vertical plane. Okay, like this. Now this B dash is as it is. After tilting this horizontal plane in upward direction, so B point is also coming here. Okay, on the B dash line. Let us see here. In here both B dash and B will coincide with each other like this. We are tilting the entire plane like this. So this plane will go in downward direction, this plane will come in the upward direction. So here give some gap equidistant from one example to another example. So I will mark B dash initially, it is 48 mm from XY line. So here do the projector line. So this is a B dash, make it dark here. This is the front view, and I told already B will also coming here after tilting the plane. Okay, how much distance it is? 21 mm. Okay, so it is coming on the same line, 21. So just make one point, don't do again one more line because both are coinciding, already we did line. So this point is B point, make it dark. So this is the front view, this is the top view of the B point in the second cube. The dimension of the B dash and B, so where B dash will come, it is 48 mm. Okay, so here just do the extension line, mark this is the 48. And where is the top view? Top view is 21 mm. Okay, so mark the smaller dimension this side. One side is bigger dimension, one side is smaller dimension. This is the 21 mm. And instead of keeping arrows, fill these arrows. The thickness should be less. Okay. Take the third point, C point here. So where is the front view of this C? As I told, front view means the observer will be standing this side. Okay. So this is the front view here for C point. Okay. This is a transparent plane, vertical plane, and transparent horizontal plane. If you see the front view this side, the front view will come here. Okay, on the vertical plane. We are marking it is C dash. How much distance it is? 18 mm distance. Okay. And then what is the top view of this C point? So this is a transparent. So this is the top view here. Or we can take top view here for the C point. If we see from the top of the C point, so C will come here. Okay, how much gap it is? 20 mm gap. So mark C point here, which is 20 mm distance. Okay, C dash is coming here, C is coming here. So this is a 3D view. So for doing the 2D view here, what I told, we are tilting this horizontal plane in clockwise direction. This part will move in upward direction like this. Okay, this plane is as it is. So C dash we have to mark same as it is. How much distance it is? 18 mm. So give some gap here, equal distance. So mark C dash initially. So it is coming on the below HP. Okay, so it is 18 mm. So this is C dash, make it dark, and this C is coming on this plane, it is moving in upward direction. This gap is 20 mm. Okay, so from this 20 mm C will come. So this is the C point, make it dark. So C dash is the front view, C is the top view. What are the dimensions of C dash? Here front view C dash, how much distance it is? 18 mm. Okay, so take one side one dimension. Just do the extension line here. This is, keep the filled arrows. This is 18. And what about C point, top view? Top view is 20 mm. Okay, so keep this arrow on the same extension line. Mark the dimension on the same extension line. This C is 20 mm. Okay, so next take D point. For D point, front view is in this direction. We are seeing the D point from this direction, and top view is from this direction. If you see front view, the D dash is coming here on the vertical plane. How much this distance? 13 mm. Okay, from 13 mm distance D dash will come. So here mark 13 mm distance. So mark this D dash here. Top view means this D point, top view will come here. Okay, on the horizontal plane. So D, how much distance it is? 45 mm distance. Again we are tilting this plane in downward direction. So this 45 mm D point will come in downward direction on the same line. Okay, so from this line we have to take 45 on the same projection line. So at 45 mark the D point. So this is the D point, make it dark. Mark the dimensions also for these points. Okay, so here as I told, for D point front view distance is 13 mm. So D dash from this line is 13 mm. Just do the extension line. Okay, mark 13 mm here. And what is this distance? Top view distance, D point is 45 mm. So here mark this side, mark smaller dimension one side, bigger one another side. Okay, as I told, it is 45 mm. Okay, just do the extension line here from D point. So take this is 45 mm. For these examples I am taking one more point. Okay, here I am taking one point, that is some I point. So I point is intersection at the both horizontal plane and vertical plane. So for front view it is coming from this direction. For the I point, top view will come from this direction. Both views will meet at the same point. That's why front view, that is I dash. Okay, top view, that is small I. Both I dash and I will come on the same point. So it is on the xy line. Already we did xy line. Both I dash and I will come on the same point. Okay, so it is 0, 0 distance from both the planes. The another example, I am taking R point. We need to draw the projections of R point. So let us take the given data. R point is 50 mm behind VP. Okay. So how to define R point? R point is on the HP, 50 mm behind VP. Okay. So according to the given values, we have to mark R point initially. Okay. So for this R point, we need to do the projections. That is front view and top view. Okay. So front view means, as I told, observer will stand here this side. So for R point, so this is the front view. And where is the top view? So from the top of the R point. Okay, if you see from the front view, that is R dash will come on this line. Okay, so here R dash will come on this line. Okay, and then if you see from the top view, small r will come, okay, on the same horizontal plane. So small r will come here. At what distance it is coming? Small r 50 mm. Okay, because we are seeing this side, we can see this gap also. Okay, so small r is coming here, but I told this horizontal plane will move in upward direction like this in 2D drawing. So this small r will move like this. This gap is 50 mm. So r dash, from r dash we need to mark 50 mm. So r will move in upward direction. So this gap is 50 mm. Mark the given dimensions. Fill this arrow. Similarly, I am taking last point here, Q point. Let us take this gap is some 60 mm. Okay, this gap from this horizontal plane. So how to define Q point? Q point is 60 mm below HP. This is a horizontal plane and on the vertical plane. Okay. So draw the projections of Q point. Projections means front view and top view. So where the front view is coming, as I told, observer is this side. So we can see the Q point here. If we see the Q point here, we can see this gap also. Okay. So front view, that is Q dash, will come at the same point. Q dash, that is 60 mm below this XY line. And top view is coming from this direction for the Q point. So where the Q point will come, it is on this line. That's why it is coming here, Q. Okay, Q is coming here. Q dash is coming at the same point, that is below HP. Okay. So we can see the Q dash below this 60 mm. Okay, here I will extend this line. So mark this Y point here. Okay, mark this Q dash 60 mm here. So what is the front view of this Q point? Q dash. And here Q will come, top view will come here. Okay, so take this is a Q here. Mark the given dimension. We can mark the dimension this side or this side. Any side we can do. So like that we can mark the dimensions. Like that we can mark projections of any given point. This type of questions, initially roughly you have to do this horizontal plane, vertical plane, you have to mark the given point. Okay, after that you have to assume front view and top view of that point and roughly mark projections of those points. And in the working sheet, in the drawing sheet, you have to do the XY line, you have to mark the projections. Here make sure you have to take both front view and top view on the same line. Okay, in all the cases, because we are taking one single point. Okay, both projections are coming on the same line. This line is called projector line. Remember the angle between XY line, that is reference line, and projector line is 90 degrees. Okay. In all the cases it is 90. So these projectile lines are perpendicular to this xy line. This is the procedure of marking the projections of the given points. If you have any doubts, please let me in comment box. If you like this video, please press the like button and subscribe my channel and share with your friends. Thank you for watching.